So we're going to take a look at a couple of your assignment ones here. So this first part, it's really hard to see some of these arrows, but you're asked to draw the vector in unit form as well as column vector form. So all of these, let's take a look at A. That one's not bad to see here. It's tough to see the arrow is going down on this one. So 1, 2, 3, 4, 5, 1, 2, 3. So it starts here and ends there. So it is going down 5 and backwards 3. So that would be vector A. And in unit vector form, that would be negative 3I minus 5j. So if we take a look at B, we can do the same. It starts here and ends up here. So it goes backwards 2, 1, 2, 3, 4, and up 4. So vector B would be negative 2, 4. So in unit vector form, that would be negative 2I plus 4j. And D is really tough to see. But let's say, might be different on yours if I highlighted it, but it's going up. So there's no X movement, and it's going up 1, 2, 3, 4, 5, 6. So it would be 0 I's plus 6 J's. So number 2 here, you're asked to find the magnitude of each vector. So if you were to draw this one, it goes over 3 and up 4. So your vector would be right here. And then to find the magnitude of the Pythagorean theorem, 3 squared plus 4 squared equals c squared. So 9 plus 14 equals 25. So our magnitude would be length 5. Let's take a look. 1, 3, so we go over 1 and down 3. So we have negative 3 squared plus 1 squared equals c squared. So that would be the square root of 10. Let's take a look at this one. So remembering that this is our x movement and our y. So it goes over 2 and down 5. And then we could set that up as well. 2 squared plus negative 5 squared. So we have 4 and 25. So we have the square root of 29. And then just remembering when it's in 3D, we extend it as well. So this would be 2 squared plus 2 squared plus 1 squared equals c squared. So we have 4, 4, and 1. So 9 equals c squared. So our magnitude would be 3. Number 3 here, P has coordinates and Q has coordinates. So we're given 2 coordinates and we need to find vector PQ and QP. So P to Q, how do we get from P to Q? 7 to 2, so we go down 5. 4 to 3, we go down 1. Whereas Q to P, we're going the opposite direction. So Q to P, going that way, we go up 5. And then 3 to 4, we go up 1. Number 4, write the vector in unit vector form. So we have to figure out what our vector is. So 2 to 1, so we go down 1. Negative 3 to 2, we go up 5. And then 5 to negative 1, we go down 6. So it would be 1i plus 5j minus 6k. And this next one, so we're given 2 vectors and we have to find u to s. So let's see, so t to s is going this way, so we have t to s. Then maybe it's going this way, t to u. And we need to find u to s. So here's our ending point. So 1 to 3. 1 to 3 is going up 3. Negative 4 to positive 4 is going up 8. 2 to negative 1 is down 3. So we could say u to s, and it's written in unit vector form, so we could do that again. 3i plus 8j minus 3k. So if you go to the back page here, A, B, and C are coordinates respectively. Find A to B. Okay, so we're going A to B. So 2 to 5. Let's see, is going up 3. 3 to 1 is going down 2. Negative 3 to 5 is going up 8. So let's show that they are collinear. Well, let's see, how do we get from B to C? Well, B to C, 5 to 8, we go up 3. 1 to negative 1, down 2. And 5 to 13, we go up 8. So they have to be collinear because it's line around the same vector. So I can't draw in 3D, but it's like saying we go over 3 and down 2, and to this next one over 3 and down 2. So it's got to be on the same line. Find the vector from A to B and hence determine the distance between the points. So from A to B, negative 1 to 4, we go up 5. 5 to 5, so that would be 0. 1 to negative 1, down 2. So if we look at that, how can we find the distance? Well, we could just do that Pythagorean theorem. So 5 squared plus 0 squared plus negative 2 squared. So we have 25 plus 4 is 29, so it would be the square root of 29. Number 8, show that the triangle ABC is isosceles and calculate CAB. Okay, so let's see. So we have triangle ABC. So here's some vectors, and they're all position vectors. So this is just saying, imagine like in the classroom, if here's like a corner from the classroom, we have all 3 of these vectors coming out. And together, whoops, that did not. Let's try that again. So it's just saying, let's say here's our position, our origin. So we have vector A, vector B, and then to C. But they form this triangle, ABC. So let's see what A to B is. Negative 5 to 6. So that is, I'm going to erase those, going up 11. 2 to 0 is down 2. 4 to 6 is up 2. B to C. 6 to 8 is going up 2. 0 to 10 is up 10. 6 to 1 is down 5. And then A to C. Negative 5 to 8 is up 13. 2 to 10 is up 8. 4 to 1 is down 3. So let's show that this is isosceles. So the distance, that magnitude from A to B, would be 11 squared plus negative 2 squared plus 2 squared. So 121 plus 4 plus 4, so the square root of 129. B to C, 2 squared plus 10 squared plus negative 5 squared. So 125 plus 4, so there's 129 again. And A to C, 13 squared plus 8 squared plus negative 3 squared. So we have 169, 64, and 9. 2, 12, 14. So we have the square root of 242. Now it also says find the angle of, what angle is it? CAB, so this angle. Well, if we were to find that angle, we could think of this as, we know these distances, so the square root of 129, square root of 129, and the square root of 242. And so we could use law of cosines here. So we could do the square root of 242 squared equals the square root of 129. I better write this over further. Sorry if you're going to run out of room. Equals the square root of 129 squared plus the square root of 129 squared minus 2 square root of 129 square root of 129 cosine of theta. So we have 242 equals 129 plus 129 minus 2 times 129 cosine of theta. And then just remember you need to keep solving this by doing that part where we chunk those together. And then you have to do the inverse cosine at the end. So number 9, given that the magnitudes equal each other, find the possible values of a. Well, magnitudes, that is that Pythagorean theorem. So a squared plus negative a squared plus 2a squared equals 2 squared plus negative 4 squared plus negative 2 squared. Well, this is a squared plus a squared, 2a squared, 4a squared equals, let's see, 4, 16 plus 4 is 20, plus another 4 is 24. 4, 5, well, this is 6a squared equals 24. Divide by 6, so a squared equals 4. So a could equal either positive or negative 2. And then this last part, number 10, find these vectors. So we're adding them. So 2, negative 3 plus negative 4, 5. So we add the x parts. So 2 plus negative 4, negative 2. Negative 3 plus 5 is 2. So let's have you try the rest of these, and then you can check them on the answer key.